So lesson 2.4, yesterday you guys got a head start on this assignment, or this lesson, because this is a topic that you've seen multiple times before, okay? So first thing we're going to talk about with slope is I want to pay attention to this equation here. Now, if you have some of this written down already, that's fine. If you want to rewrite it how I am, that's cool too, okay? So what is this equation called? Slope-intercept form. Yep, slope-intercept form. No, we are not going to be graphing these. Okay, we're mostly just going to be talking about the key features of the graph. We're not going to be graphing. So in that equation, what are two things that are important to us? Yeah.
Like the M is the slope.
Good. M stands for our slope. And what else?
The B is the y.
B is our y-intercept. Again, we're not going to be graphing. Okay, but those are the two important parts to that. Okay. Specifically talking with slope, what do we know about slope? Yeah, it's rise over run, okay? Or a lot of you think rise is how much we go up, so you think of the y values, and the run is how much we go side to side, so you think of the x values, okay? So slope is we're counting that rise over run, okay? Couple slopes I want to talk about. Go ahead and draw these graphs real quick on your paper. Okay, this is on your homework, so go ahead and draw them so you have them. What if I had a line that looks like this? What's the slope of that line? Let's talk about it. So, am I rising at all? Like, am I going up and down? Yes. Okay, so I'm just going to represent that as x right now. Am I going side to side at all? No. Like, our run is nothing, so our run is 0. Can I divide a number by 0? No. What does your calculator tell you? It doesn't tell you 0. It tells you there's an error, right? Because you can't divide something by 0. So this slope is actually called undefined. Okay, an example I use sometimes because I know we can mix them up a little bit if you don't go through this step. Okay, if I'm walking, I'm going to use this here. If I'm walking on this line and I hit this slope here, can I go anywhere? No. I can't, right? So that's an undefined slope. Next one I want to talk about, if my slope looks like this. Okay, let's think about it, rise over run here. Am I going up or down at all? No, so that would be 0. Am I going side to side? Yes, okay, I'm going to represent that as x right now. What is 0 divided by anything? 0. So this one does have a slope of 0. Okay, so if I'm walking on this line, do I ever stop? No, I can keep going forever, right? So there is a defined slope there. Okay. Questions about those two? Those are kind of the funky ones. Okay. One more thing with slope is when we're given 2 points. Okay, so let's just go ahead and go right into example 1 on your notes. Let's take notes about... All right, go ahead and let's talk about parallel slope. Or I'm going to say parallel lines. What do we know about the slopes of parallel lines? They're the same slope. Yep, so we know parallel lines have the same slope. So if line 1 has a slope or m of 2, what would the slope of line 2 be? If they're the same. It would also be 2, right? Okay. What if we had perpendicular lines? What'd you say? Yeah, when they intersect, they make a 90-degree angle. What do we know about their slopes? Are they the same anymore? No, because we know they cross, right? What do we know about the slopes? Did anyone figure it out yesterday? What do we have to do to the slope? It's opposite and reciprocal. So slopes are opposite reciprocals. Okay, let's break this down a little bit. I'll tell you, line 1 is, the slope is 1/2. Let's talk about what line 2 would be. Okay, what does opposite mean in math? Right, what's the opposite of positive 2? Negative 2. What's the opposite of negative 5? Positive 5, okay? So opposites have to deal with positives and negatives. What's the slope of this, positive or negative? It's positive, so what would the slope of our perpendicular line be? Negative, so we flip the sign. What does reciprocal mean? It's where you flip the fraction, right? So whatever's on the top turns to bottom, same thing for bottom to top. So 1/2 turns to what? 2, and you can think of it as over 1, or you can just think -2. Okay, let's try one more example with that. If I have line 1 is, the slope is -2/5, what would the slope of line 2 be if it's perpendicular to that? 5/2, right? Change the sign to positive and we flip the fraction. Okay. So on example 1, you should see this picture here, yeah? Okay, I'm going to focus on this right here. They are talking about, they want to know if these two lines right here are parallel. How many of you looked at it and said, yeah, they look parallel? A lot of us did, right? You're like, yeah, they look parallel. How can we prove that? If they don't hit each other, and we can use an equation, right? I'm getting a little ahead of myself here. So on this example, it wants to know if the lines are parallel. Okay. Notice here how they give us coordinates. Okay. Is there a specific equation we can use when we are given coordinates to find what the slope is? A lot of you are nodding, right? It's this equation here that we talked about yesterday. It's the y2 minus y1 over x2 minus x1. Okay, so on this one, it gives us the two coordinates for this line here. What can I label those two coordinates to help me out with? For example, I could label 0, 16 as x1, y1. What can I label 6, 24 as? x2, y2. We have all of the values. Now we can plug them into our formula here. So we get 24 minus, what's y1? 16 divided by x2. 6 minus 0. What is 24 minus 16? 8. 6 minus 0? 6. With slopes, we want simplest form. What does that mean? Is 8 over 6 in simplest form? No, why not? Yeah, you can divide it by 2, right? A number that goes into both of those is 2. So we get our answer as 4/3. That's the slope of our first line. Okay. How do we know if it's parallel to the other one? How do we figure out the slope of the other one? Same thing, right? This time it gives us these two coordinates, so I can treat 0, 0 as x1, y1. 6, 8 can be x2, y2. So following the same formula from up above, we get y2 is 8 minus 0 over 6 minus 0. So we end up getting 8 over 6. Simplified form would be 4/3. What do you notice about the two slopes here? They are the same, so are the two lines parallel? Yes, since the slopes are the same, we know those two lines that they gave us are parallel. Okay, what if there was one little difference? What if this one turned out to be negative? Would they be parallel anymore? No, they have to be the exact same. Okay? All right, let's go ahead and look at example 2. You should see this graph here, except this is supposed to be a T. Okay? On your example, it says, are lines T and Q in the graph parallel? How many of you looked at it and said, meh, yeah, pretty close? Okay? Some people actually continue drawing this out even onto my desk. Don't do that. Okay? How do we find the slope when we're given just a graph? You could find the coordinates and use the formula again. There's a much easier way. What could you count? Rise over run, right? You can count the boxes for rise over run. Now, what's going to be helpful to get a perfect slope? If I had to start, if I pick this here, is that a good starting point? Probably not, right? We want a perfect point here. So what I mean by a perfect point is we want it to cross at one of the unit squares. Okay? So for T and Q, we want to find the slope of both of those. So I'm going to start with line T here. I want to find two perfect points on this line in order to count rise over run. Okay? I see one right here. Do you agree? Okay, and I also see one here, yeah? Okay. Biggest thing is we want to know if our line is positive or negative. So if it's positive, we're going up. If it's negative, it's going down. So right now, is t positive or negative? It is positive. Okay, how many do we rise? 1. Rise 1. How many do we run? So we get 1/3. Can I simplify that or do anything with that? No. So our slope for t is 1/3. Now we're going to do the same thing for q. We want to find 2 perfect points. So I see 1 here. Is this a perfect point? No. And I see 1 here. So what is my rise? 2. And my run is 5. So we get a slope of 2/5. Can I simplify 2/5? No. Are those lines parallel? Why? They're not parallel. Why are they not parallel? They're not the same, okay? If it was parallel to t, what would q's slope have to be? 1/3. If q was parallel to t, what would its slope have to be? 2/5. I worded that weird, but you got my point. Okay. Did we get the correct positive or negative here? Yep. A lot of the times we can look over that whole thing, but we do want to make sure we get the correct positive or negative slope there. Okay. Okay, except m is t now. Okay, same thing here. On part A, it wants to know if h and L are perpendicular. How do we determine if they're perpendicular? What'd you say? Yeah, we have to find the slopes, right? You could look at this and be like, yeah, they cross, but just because they cross, does that mean they're perpendicular to each other? No. For perpendicular, remember, it has to make what kind of angle? Has to make a 90-degree angle. Yep, so we got to check for perpendicular here. We want to find 2 perfect points. I'm going to do line H first. First of all, is H a positive or negative slope? It's negative because our line's going down. Okay, so find 2 perfect points on H. I see 1 here. And this end point would be 1. Okay. What's my rise? How many do I go up or down? 2. So we have -2. What's my run? How many do I go over? 3. So our slope for H is -2/3. Now we want to do the same thing for L. If it is perpendicular, what would our slope for L have to be? 3/2. Positive 3/2. Right now, are we positive? Or is L positive is what I'm asking? Yes, okay, so I'm going to use this perfect point again since it's on L. Okay, and I'm going to find another one, which is here. Okay, what is my rise? What's the rise? It is 5. Yep, because we're going over. Thank you. It is 5. What's the run? 2. Are those perpendicular? No. Okay, because again, we said that if it was perpendicular to H, it would have to be 3/2. What if it was perpendicular to L? It would have to be, what else do I need with that? The negative, yep. So make sure you're switching the sign and switching the direction of the fraction, okay? Now we're going to move on to example 4. I know you don't have space there, so if you want to find extra space somewhere, even off to the side, I'm not going to do example 5 or anything below that, so you can use that too. Okay, so on example 4, it gives us y equals -3x plus 2 with a point that it goes through of 3, 1. Okay, on these, it wants you to find a parallel line to that equation that goes through this point and a perpendicular line to that equation that goes through that point. Okay, so we're kind of doing 2 different things here. Just to start, what is my original slope for this line? It is -3, right? It's because it's in the spot of that M, okay? For my parallel slope, I always signify it with 2 parallel lines in the M after it, parallel slope. What would our parallel slope have to be? What do we know about parallel slopes? Or parallel lines? They're the same slope. So if our slope for the original is -3, what does our slope for the parallel line have to be? Also a -3, okay? What's the magic equation that we're going to use? What's the slope-intercept form? There we go. Yep, we're going to use y equals mx plus b to figure out what our new equation is going to be. Okay? This point right here, that's where the line goes through. That's going to serve as our x and our y point. So we're going to plug in everything that we know so far. What's my y value? Yep, 1 because of that coordinate. What's our slope? -3. What's x? What's our x value? 3. And then we don't know what b is, right? So I'm just going to put plus b. This just turned into an algebra problem trying to get b by itself here. What's 3 times, -3 times 3? -9 plus b. What would my last step be to get b by itself? Add 9. So we end up getting 10 equals b. Remember at the beginning of today, we talked about 2 important points that we need, right? Or 2 important things for the equation, and those were our m and our b. Once you have those 2 things, you can write your new equation. Okay, so this turns into y equals, what was our slope? -3x, and our b is 10. This is our parallel equation to this line at our original that goes through this point. Okay, so there's the parallel equation. Now it wants us to do the same thing, but with the perpendicular equation. So what's the only thing that's going to change? The slope, right? So perpendicular, you use an upside down T. So perpendicular slope. What is perpendicular to -3? Careful. I agree with the positive part, but we also want to flip it. So remember, this is technically 3 over 1. So it's going to be positive 1/3. Yep, because we also have to flip the sign. Yep. So now we're still going to use our slope-intercept form, y equals mx plus b, to figure out what our equation is going to be. So what's my y value? Again, from this point up here. 1 equals our slope. 1/3. X. 3. Up, and since we have a fraction, we can think of this as 3 over 1 to kind of help us out a little bit. And then we have plus b. Now we're simplifying. Remember when you can cancel some things out from top to bottom? What happens to these 3's? They can cancel, or you can think, if I have 1/3 times 1, or 3 over 1, you just multiply straight across. So that turns into 3 over 3, which is 1. Yep. What do I do from here? Subtract 1. So we get 0 equals b. And then how do I write my answer or my equation here? What's our perpendicular slope? 1/3 x. What's our b? It would be plus 0. Do I need to write plus 0? No. Okay, if you did, I would not count you wrong for that, but you don't need the plus 0. Okay? All right. Let's look at example 4b. We have y equals 3/4 x minus 5, and our coordinate is 12, -2. Again, we're doing the same thing. We're going to focus on parallel first. What is my original slope? 3/4. What would my slope for the parallel line be? Yep, it's going to stay the same, right? Remember, parallel slopes stay the same. What's our magic equation we're going to use? Yep, y equals mx plus b. Plugging in what we know, remember this point here, that gives us our x and our y. What's our y value? -2 equals slope 3/4. Our x value is 12. Treat that as over 1. And then we have plus b. Little review again. What can I do with this 4 and 12? You can simplify, right? How many times does 4 go into 12? 3. So that turns into 3 times 3, which is 9 plus b. What do I do from here? Subtract 9. So we get -11 equals b. A lot of you are going to go like this. Is that my answer? No, it wants the parallel equation. Okay, so what would our equation be? Yep, you could do plus negative 11 or you can do minus 11. Good. Now we want to do the perpendicular slope. What's going to change? The slope's going to change, okay? So my original was that 3 over 4. What is my perpendicular slope going to be? Negative 4/3. Okay, so again, magic equation here, y equals mx plus b. What was our y value to our coordinate? Negative 2. Yep, using that same coordinate there. Negative 2 equals, our perpendicular slope is negative 4/3. What's our x coordinate? 12. And then plus b. Again, what can I do with this 12 and 3 here? Yep, how many times does 12 go into 3? 4. So we have negative 4 times 4, which is negative 16 plus b. What do I do from here? Yep. So we get 14 equals b. Is that my answer? Nope. Want to write the equation. What would my equation be? Yep. It'd be plus 14. Yep. Good job. All right.